Hi there, it's Sam Kanu, and this video recording is for the purpose of submission with high distinction task. My full name is Samarpan Gupta Kanu, and my student ID is 5027031. In this task, we were asked to analyze and visualize YouTube videos based on the metadata and the data from the YouTube application, from the YouTube platform. To be more specific, we were asked to analyze the sentiment of comment and video titles on YouTube videos over a specific time period, focusing on months between January 2020 to January 2021. The first step that I have implemented is dropping rows with missing values. We are cleaning the data by removing rows that have missing value in the key column. For example, we don't want any rows in video df data frame that don't have both video ID and channel ID. So we're going to drop those by the help of function drop any. Similarly, we drop rows in comment df as well that don't have video ID, comment text, and comment ID as well. This ensures we are only working with rows that only contains a meaningful information to it. Secondly, what we are doing is we are dropping the unnecessary column. We are removing some column that we don't need for our analysis. So we are just simplifying the data frame for which makes us easier to visualize the data later on. Also, I also tried to fill the missing values for categorical columns such as channel title, video title. So what we are doing is we are trying to handle any missing values in the categorical column like channel title and video title by replacing them with a word unknown. So if there's any null values in any of those columns, then those will be replaced by unknowns. Speaking of the actual analysis part of this assignment, I have chose to do question number E.1, which demands us to find the monthly distribution of positive, negative, and neutral sentiments in the video title and comments from a specific time period, and use visualization to answer the question for different news publishers. Which in this case we have got 4 different news publishers. So first of all, we load the videos data set and filter it to only include the data between January of 2020 to 2021. This ensures we are only working with the relevant data of a relevant time period. Next, what we are doing over here is we are applying a callback function to each rows. So we want to analyze the sentiment of video titles. So we add a new column called sentiment, and we apply a get sentiment function to each rows in the data frame. The axis one suggests that instead of going column by column, let's go row by row. So this is what we are doing over in this code block. After that, we are grouping the data by month, channel, and sentiment. As you can see over here, the group by function is taking three columns as a parameter. After adding the sentiment, we group the data by published at month, channel title, and sentiment to count how many videos fall into each sentiment category. We now have a data frame. After the group month will be a data frame that shows the count of each sentiment for every month and channel. After grouping the data frame, we're gonna make it ready for plotting by pivoting the data frame. We use pivot table to restructure data frame so that each sentiment get its own column and missing values are filled with zeros. This makes it easier to plot sentiments over time. So we are using pivot table, which basically is a way for us to restructure the data frame, which makes it easier to deal with it. The column name passed as an index remain unchanged, and they become the index for the new data frame. And the column parameter grabs the unique values in column passed as a parameter, which in this case is sentiment, and creates their own column with values passed as values. So whatever the unique values in sentiment are, it creates a separate column for each of those unique value, and the values for those columns will be the count, which is coming from a grouped by data frame. After pivoting the table, we also got a melt the data frame. As we know, melt function from pandas is used to convert the data frame from a wider format to a lengthier format, so that each row of the data frame has only one meaning attached to it. Instead of having one data point attached to two different attributes, melt converts those two attributes in a single row, so that one row only contains one piece of information. As you can see, our value vars has positive, negative, and neutral, which means there'll be a column for variable, and the variable column may have positive, negative, and neutral values. Let me just print it out to show the difference between the melted database plot data title. There we go. So we're going to run. Yep, there we go. As you can see here, each column only has one information attached to it. So although there's a repetition between the columns, but each row only has one information attached to it. So the published at month, channel title, and sentiment. This makes it much more easier for us to visualize the data. In next block of code, we are handling any missing months in the date. For any months that are missing for a channel, we create rows with default values of 0 for each sentiment. We are iterating over the group by object, that is group by channel title, and grabbing the channel, which is the key of the group by object, and the actual group, and checking if there's any missing month in the group. If there is, then we are adding that we are creating a new data frame with that month and the default value to 0, and sentiment could be for each sentiment, and adding this and then concatenating this new data frame into the existing plot data title, that is the one that we melted out. we got to make sure that we perform this step, which is basically just adding a dummy value for the months that are not present in the data frame. We got to make sure that we do this because while plotting, if months are missed, then real plot, which we are using, which is a function from a SNS Cbron and which we are using to plot the line graph, we'll just skip the month that is not there and continue from the another consecutive value. But since the x sticks are predefined over here, so x sticks will be a list of values which will represent each month from the year 2020 January to the year 2021 January. So each month will be a member of a list of this month's list. And since we are hard coding that value, not doing this step, not adding a dummy value to the months that are not there, will misalign the graph since few months are already skipped. Therefore, adding zero values for the miss column allows RealPlot, the function, to be aware of missing months and draw accordingly. After that, what we are doing is just sorting the values based on the channel title, published at month, and sentiment. And we're just resetting the index, which basically means taking the current index and putting them into the normal column and adding a new index. Or actually, when the drop is true, it takes the old index and drops that and adds a new index in place of the old index. Next, we are using Seaborn library, as I've already discussed, to plot the line graph. We use RealPlot for line plot with hue sentiment to color the lines by sentiment and use call is equals to channel title to separate the plots by channel. Speaking of the observation that we can take away from this graph is, as you can very clearly see, all the major news channels show a significant spike in sentiment activity during the March, April, or so to say from February to April 2020, which coincides with the early stage of the COVID-19 pandemic. However, the magnitude of different news channels may be different. For example, Fox News shows the most drastic spike, like it's almost nearly reaching 25 sentiments count, which is predominantly neutral sentiment. And similarly, BBC News and MSNBC News show more. They are like more moderate increase from 8 to 9 counts for each sentiments. Similarly, the data reveals that the distinct sentiment patterns across networks. For example, Fox News consistently shows that the highest proportion of neutral sentiments compared to the other channels, suggesting that the Fox News are more factual and straightforward. Now, moving on to the second part of the question, since the question has two parts, first we have to analyze the video titles, and the second is comments. Moving on to the comments part, comment part is basically similar to the videos part. As you can see, we are basically filtering out the data frame. But what is different is but the difference is, instead of using the default get sentiment function, what we are doing is we are defining a function. We are defining a function called decide component sentiment that calculates the sentiment of a comment. If comment is a reply, we check the sentiment of a parent comment and adjust the sentiment accordingly. As you can see, it's just a bunch of if-else statement that basically says if parent sentiment is neutral, then whatever is the sentiment of a child, be that a sentiment of the entire text. But if the parent sentiment is positive, and if the and if the child sentiment is also positive, then the final sentiment should also be positive. While if the parent sentiment is negative and the child sentiment is positive, then the final sentiment should be negative, because if you're appreciating something negative, that should also be considered as a negative. So this is something that I implemented on my own to customize the sentiment categorizing function part. The plot is wrapped by a channel, and each subplot shows the sentiment breakdown per month. As you can see over this, as you can see in this diagram, the color represents different sentiments. So green color represents the light green color represents the neutral sentiments, while the dark green color represents the negative sentiment, and the black color represents the positive sentiment. And it is categorized based on the channel name as well. So I've used the x-axis for the comment. I've used the x-axis to be the comment date and y-axis to be the value, while the hue is set to the sentiment, which basically means the color coordination will be based on the unique value of sentiment. And I've used the call is equals to 2, which kind of creates a 2 by 2 matrix, and each position in the matrix will be assigned to a certain graph. For the customization purpose, again, I've used the axis flat. I've used the property of the cat plot to set the custom labels for each axis. As for the observation of this section, as you can see, there's a very similar story to what we had seen in the previous part. March 2020 marked the highest engagement peak across all the news channels, with Fox News and MSNBC leading the surge with around 140 to 160 comments. This massive spike in engagement clearly shows how intensively viewers were reacting to the early COVID-19 coverage. This also coincides with the analysis that we did in the previous part, where the engagement was highest in the month of February to April. And similar is the case with here. So engagement is higher between the month of February to April. And notably, one more thing that is very clear is there is a clear cooling off trend as 2020 progressed. So after March, April peak, comment numbers gradually decrease across all channels, eventually settling at a much lower levels by year's end. While doing this assignment, I did face quite a lot of obstacles, but one of the most notable obstacles was when I was using line graph first half of the question. Then, since the months were missed in between, the real plot function was not considering the fact that few months are missing. So at the end, in a holistic view, the line graph was consolidated into few months, and the ticks were not aligned with the correct progression of the line graph. So what I did was, as I said, as I've already mentioned, I added some extra, I added some dummy values to the data frame so that the line graph perfectly aligns with the ticks that we have got. So in the final result is the ticks, the labels for the x-axis are perfectly aligned with the graph created by the line, by the real plot, in a sense that it actually demonstrates the real data. While completing this SD assignment, I did face a lot of obstacles, but one of the other challenge was to make sure that the parents' sentiments and the reply sentiments were perfectly matching with one another. So to implement this function, I had to do some research on how things are linked together and how we can access different data frame. The other obstacle that I faced was handling missing data. In this case, when a comment is a reply and has a parent, we need to adjust its sentiment based on the sentiment of the parents. The challenge arises if the parent sentiment is missing or if the parent component itself doesn't exist. So this forces us to handle edge cases. To address this issue, I had to create a custom function that handles both missing sentiments for replies and the parents and ensures that comments without parent still have their sentiment calculated. This extra layer of logic can easily lead to errors and inaccurate data if not carefully implemented. Apart from this, I had a pretty good learning from this assignment. Thank you.